Welcome to the class. In today's class, we'll solve some more problems from the exercise 2.2. Let us discuss question number 9. In question number 9, I'll give you a hint. Here you can substitute x is equal to a sine theta, and then simplifying you'll get the result. In 10th, you can write x is equal to a tan theta. So the expression inside the bracket will become tan 3 theta. Similarly, in the first case, the expression inside the square root will become cos theta, and finally it will become tan inverse tan theta. Now we will solve question number 11. Question number 11 is find the value of each of the following. Tan inverse 2 times cos bracket के अंदर 2 sin inverse 1 by 2. So let us start with the innermost bracket first. Let us assume sin inverse 1 by 2 is equal to theta. This implies sin theta is equal to 1 by 2. So the expression will become tan inverse 2 cos 2 theta. Now the value of cos 2 theta in terms of sin theta is 1 minus 2 sin square theta. This is the formula for cos 2 theta. Now we'll have tan inverse 2. Now we have the value of sin theta with us, so it is 1 by 2. Tan inverse 2, 1 minus, after simplifying you'll get 1 by 2. Tan inverse 2 into half is equal to tan inverse 1 is equal to pi by 4. This is the answer for the 11th one. Now comes the second 12th question. 12th question is simplify again cot tan inverse a plus cot inverse a. From property number 1 we have 1 by tan inverse a is equal to cot inverse a. So second expression will become tan inverse 1 by a. First property cot. Now applying the fifth property, tan inverse x plus tan inverse y formula. So it will be tan inverse a plus 1 by a divided by 1 minus a into 1 by a. Cot tan inverse a square plus 1 divided by a divided by 1 minus 1. तो ये बन जाएगा cot into tan inverse something by 0 not defined, and 10 not defined कब होता है? टेन नॉट डिफाइंड होता है पाई बाई 2 पर. cot pi by 2 and cot pi by 2 is 0. So this is the answer of question number 12. In question number 13, this is the standard formula for tan 2x, tan inverse x, and this is the standard formula for 2 tan inverse y. Take out 2 common and apply the formula tan inverse x plus tan inverse y, and you will get the answer. In question number 14, you can transpose this sign, or taking inverse on both the side, you will get sin inverse 1 by 5 plus cos inverse x is equal to sin inverse 1, and sin inverse 1 is pi by 2. So So on the left hand side we'll have sine inverse 1 by 5 plus cos inverse x is equal to 1 by 2. This also looks like a formula. Applying the formula, we'll conclude that x is equal to 1 by 5 because sine inverse x plus cos inverse x is equal to pi by 2. Here first term is sine inverse 1 by 5 and the second term is cos inverse x and is equal to pi by 2. So comparing both, you get x is equal to 1 by 5. 15th वाले को सॉल्व कर लेते हैं. आंसर इसका हो जाएगा. Now left hand side is x minus 1 upon x minus 2 plus tan inverse x plus 1 over x plus 2 is equal to pi by 2. Applying property number 4, that is tan inverse x plus tan inverse y formula. Tan inverse x minus 1 upon x plus 1 upon x plus 2 divided by 1 minus x minus 1 over x minus 2 into x plus 1 over x plus 2 is equal to pi by 4. Pi by 4. So transposing this tan inverse x to this side, meaning taking the tan on both the side, this side it will get cancelled and that side we will add 10 pi by 4. Numerator will become x square plus x minus 2 x square minus x minus 2 divided by x square minus 4 divided by x square minus 4 minus x square minus 1 divided by x square minus 4 is equal to 10 of pi by 4. Taking 10 on both the side. Taking 10 on both the side. This side, both the inverse and the function will get cancelled each other. And right side will become tan inverse pi by 4. And we know that tan inverse pi by 4 is 1. Now, this term and this term will cancel each other. We'll have now what you will get 2x square minus 4 in the numerator, 2x square minus 4 in the numerator, denominator will become minus 3, and on the right side we'll have 10 pi by 4 is equal to 1. It means that 2x square minus 4 is equal to minus 3, 2x square is equal to 4 minus 3, 2x square is equal to 1, x square is 1 by 2, x is equal to plus or minus 1 by root 2 is the answer. So let us solve question number 16. Question number 16 is sine inverse sine 2 pi by 3. We know that sine inverse of sine x is equal to x. If x lies between minus pi by 2 and plus pi by 2, this is the range of the sine inverse function. But अगर यहाँ पे apply करते हैं सीधे सीधे, if you cancel this and this, you get 2 pi by 3. 2 pi by 3 does not falls in this range. Therefore, we have to do some modifications. Again, the question is sine inverse sine 2 pi by 3. So, sine 2 pi by 3 can be written as pi minus pi by 3. Sine inverse sine pi by 3 as sine pi minus theta is equal to sine theta. In second quadrant, sine is positive. First quadrant, second quadrant, third quadrant, fourth quadrant. So now this angle comes within the range of the cos and sin inverse function. इन दोनों के बीच में आता है ये. So answer will be pi by 3. Next is tan inverse tan 3 pi by 4. 17 tan inverse tan 3 pi by 4. Here also the range of tan inverse function is open interval minus pi by 2 to plus pi by 2. This value is much higher than plus pi by 2. So the angle 3 pi by 4 can be written as pi minus pi by 4. Tan inverse 10, and we know that tan pi minus theta is equal to minus tan theta. Tan inverse 10 minus pi by 4, property number 2. So this is pi by 4. Now the 18th question. Tan of sin inverse 3 by 5 plus cot inverse 3 by 2. Tan of. Now if you take sin inverse 3 by 5 is equal to theta, then the side of this triangle will be 3, 5 and 4. So we can find the value of tan theta. This value will become tan inverse 3 by 4. Here we have written the angle, the same angle in the sine form, and here we have written the same angle in cos form. Really, for the second part, if you take cot inverse 3 by 2 is equal to say phi, so angle phi will become base divided by perpendicular 3 by 2. Now tan will be, this will be tan inverse 2 by 3. So applying property number 5, tan inverse x plus tan inverse y, inside the bracket tan of, this will become tan inverse 3 by 4 plus 2 by 3 divided by 1 minus 3 by 4 into 2 by 3. Tan inverse tan of tan inverse 9 plus 8 divided by 12 divided by 12 minus 6 by 12. The second term and the last term will cancel each other. We are left with tan inverse 17 by 6, that is 17 by 6. 17 by 6 is the answer for question number 18. Remaining three questions are objective question. You can do yourself. Just substitute the value given in the option A, B, C, D and check with which option satisfies this value, and that will be the answer. Let us solve some question from miscellaneous exercise now. The 9th question of miscellaneous exercise is prove that tan inverse root x equal to 1 by 2 cos inverse 1 minus x upon 1 plus x. यहाँ पे हम फॉर्मूला अप्लाई कर लेंगे 6 का थर्ड वाला जो फॉर्मूला है वो अप्लाई कर लेंगे. After transposing this 2 to this side, the left side will become 2 tan inverse root x, and there we'll apply this formula. Now the 10th problem. Cot inverse under the root 1 plus sin x plus under the root 1 minus sin x divided by 1 under the root 1 plus sin x minus under the root 1 minus sin x is equal to x by 2, where x belongs to open interval 0 to pi by 4. 1 minus sin x can be written as sin square x by 2 plus cos square x by 2 minus 2 sin x by 2 cos x by 2. This sin x we have written as 2 sin x by 2 cos x by 2, formula which we have learned in class 11th. 1 minus sin x now will become cos x by 2 minus sin x by 2 होल स्क्वायर. आप कहोगे कि sin x by 2 minus cos x by 2 क्यों नहीं हुआ सर? Here the range is given 0 to pi by 4. 0 to pi by 4. 0 to pi by 4 में क्या होता है, जो ग्राफ होता है cos का, this is the graph for cos and this is the graph for the sine function, and this is the point pi by 4. From 0 to pi by 2, cos x by 2 or cos x is greater than sin x when x is between 0 and pi by 4, cos x is greater than sin x. That is why when we are taking positive square root, we will take x by 2, cos x by 2 minus sin x by 2. In the given domain, cos x is greater than sin x. From 0 to pi by 4, cos x is greater than sin x. That is why we are taking here cos x by 2 minus sin x by 2, not sin x by 2 minus cos x by 2. In 11th question, you have given hint, put x equal to cos 2 theta. In 12th question, you can take 9 by 4 common from both the sides and you can cancel that common portion. On the left hand side, then you are left with pi by 2 minus sin inverse 1 by 3, and the right side will become sin inverse 2 root 2 by 3. Now you can bring this sin inverse 1 by 3 to the other side, and solving the right side you will get pi by 2 then. Okay, remaining one here also on the left hand side you can apply property 6, third part. 2 tan inverse x equal to tan inverse 2 tan x divided by 1 minus tan square x. Same in the question number 14. Transpose this 2 to this side and then apply the same property 6, formula number 3, you'll get the RHS. Remaining problems 15, 16 and 17, these are objective die question. You substitute the value and check which option is appropriate. So this exercise, this chapter is over now. In next lesson we'll learn about matrices. Until then, keep learning. Thank you.